So coming to the first problem, show that the spheres x square plus y square plus z square plus 2x minus 4y minus 6z plus 10 is equal to 0, and we are having one more square, that is x square plus y square plus z square minus 6x minus 4y minus 12z plus 40 is equal to 0. So show that the two spheres touch each other externally, also find the point of contact, okay. So which is very very important model. Okay, so I'm explaining you one problem, so just listen carefully. So coming to the solution, so first we have to write the given spheres. So the given spheres are, so the first one is x square plus y square plus z square plus 2x minus 4y minus 6z plus 10 is equal to 0. So treat this as 1. And the second sphere is x square plus y square plus z square minus 6x minus 4y minus 12z plus 40 is equal to 0. So treat this as second equation. So now first we have to find the centers for both the spheres and radius for both the spheres. So now I am finding the center one, which means the center for the first sphere. Okay. So how can we write the center directly for a particular sphere? So it is nothing but we have to write the coefficients of x, y, z to half of the coefficients, and also we have to change the sign for those coefficients. So since we are having 2 as x coefficient in equation 1, so we have to write the half of the coefficient, and also we have to change the sign so that we get minus 1. So coming to the y coefficient, we are having minus 4, so that we have to write only half of that minus 4, that is minus 2, and once again we have to change the sign so that we get 2. Okay. So and similarly for z coefficient also we have to write the half of the coefficient, and also we have to change the sign, so that is nothing but 3. So if you can't understand this in this way, how to write the center, so then you can go to compare the given equation with the standard form, that is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus t is equal to 0. So we have to compare the given equation with that particular equation, and we have to write the values of u comma v comma w, and then we have to write the formula for the center, that is minus u comma minus v comma minus w. So in that way also we can find the center. Okay, but here I am directly finding the center. Okay, that is C1. And coming to the C2, here also we have to write the half of the coefficients of x, y, z, and also we have to change the signs. So that is 3 comma 2 comma 6, because all the coefficients of x, y, z are negative, so that we have to write all the terms in the center are positive, and also we have to write half of the coefficients. So 6 we are having, so that I have to write 3. 4 is nothing but 2, and 12 I have written 6. Okay, this is C1 and C2. So now for radius R1, we have to write the formula for radius is square root of u square plus v square plus w square. It means minus 1 whole square is 1, plus 2 square is 4, plus 3 square is 9, minus d. So it is nothing but the coefficient, the constant term in the first sphere, that is 10. Okay, this is equal to, so root 4 we get. So we get root 4. Root 4 is nothing but 2. So this is R1, and coming to the radius R2, this is equal to square root of, so 3 square 9 plus 4 plus 6 are 36 minus 40 minus d. In the second sphere equation, we are having the constant is 40, so that we have to write minus 40. Minus d is the, so we have to write minus 40. So once again we get root 9. Root 9 is nothing but 3. Okay. So after finding the centers and radius, uh, next we have to check whether the two spheres touch each other externally or internally. It means first we have to find the distance between C1 and C2. So that now I am finding C1, C2. This is nothing but square root of, we are having a formula that x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula we are having to find the distance between 2 points. So you can treat center 1 as x1, y1, z1 and center 2 as x2, y2, z2. So then we have to substitute the values in this formula so that we get 3 minus of minus. So we get 4 whole square plus 2 minus 2. So that is 0 whole square plus 6 minus 3, that is 3 whole square. So it means we get 16 plus 9. 4 square is 16 plus 9 square is 3 square is 9. So that we get root 25. So root 25 is nothing but 5. So the distance between C1 and C2 is 5. Now I am going to find the R1 plus R2. So R1 plus R2 is equal to 2 plus 3. That is also 5. So it means what happens? Therefore, the distance between C1 and C2 is equal to R1 plus R2. So whenever this happens, so we say that therefore the two spheres touch each other externally. Okay. I'm also going to draw you diagram. So suppose this is the one sphere. This is canvas sphere. So this is C1 and this is C2. So the distance between C1 and C2 clearly equals to the R1 plus R2. This is R1 and this is R2. So the distance between R1 plus R2, so C1 and C2 is equal to the sum of the radius of both the spheres. If this happens, then we say that the two spheres touch each other externally. So now we have to find the point of contact. Okay. So I'm treating the point of contact as P. So now I'm going to find that P. Okay. So whenever the two spheres touch each other externally, so then the point of contact is nothing but it divides the C1, C2 in the ratio R1 to R2 internally. Okay. So we are having this point internal point. We treat this point as an internal point. Okay. Now we have to find that particular point. So I'm writing that P be a point of contact. Then P divides C1, C2 in the ratio R1 is to R2 internally. So therefore, we are having a formula which we have studied in our earlier classes. That is, P is equal to mx2 plus mx1 by m plus n, comma my2 plus my1 by m plus n, comma mz2 plus nz1 by m plus n. So this is the formula we are having whenever we want to find the point of contact which divides C1, C2 in the ratio R1 to R2 internally. Suppose if you want to find the point of contact externally, so we have to put minus in place of plus in this formula. Okay. Here m is to n. Here we treat the ratio R1 is to R2 as m and n, and the points center, the points in the center 1 as x1 by 1 z1, and the points in center 2 as x2 by 2 z2. Okay. So here I'm writing once again the center 1. So C1 is equal to, so what is C1 minus 1, 2, 3. So that we have to write minus 1 comma 2 comma 3 and C2. C2 is nothing but 3 comma 2 comma 6. So 3, 2, 6. 3, 2, 6. And the m is to n. So the ratio is, what is R1? R1 is 2 and R2 is 3. So if you written in this way, then it is easy for us to substitute the values in the formula. So this is equal to, here m is nothing but 2. mx2. So treat this as x1, this is y1, and this is z1, and this is x2, this is y2, and this is z2, and this is m, and this is m. Okay. So now I am directly substituting the values in the formula. So mx2, so 2 3s are 6, plus nx1 minus 2, sorry, minus 3. So n is nothing but 3, x1 is minus 1. 3 into minus 1 is minus 3 by m plus n, that is 5, comma. Once again, m by 2, so 2 2s are 4, plus 3 2s are 6. M plus n is 5. Next, mz2, so 2 6 are 12, plus 3 3s are 9 by m plus n, that is 5. So finally we get, so 3 by 5 comma 10 by 5 comma 21 by 5. So this is the point of contact whenever the two spheres touch each other externally. Okay, here we can simplify it as 3 by 5 comma 10 by 5 is nothing but 2 comma 21 by 5. So in this way we can find the point of contact. So whenever two spheres touch each other externally. Okay, so I am giving you one more problem in this model. So try this particular problem. Okay, right. I'm writing the second problem. So that the spheres x square plus y square plus z square minus 25 is equal to 0, and x square plus y square plus z square minus 24x minus 40y minus 18z plus 225 is equal to 0. Touch externally at the point 12 by 5 comma 4 comma 9 by 5. Here it was also given that what is the point of contact. Okay, we have to verify whether it is correct or not. So first of all, we have to say that the two spheres touch each other externally. It means C1 C2 is equal to R1 plus R2. We have to verify that condition, and after verifying that condition, we have to find the point of contact, and the point of contact answer was also given in this particular problem. So this answer should be get while finding the point of contact. Okay, right. Thank you.